Hey, finance students, welcome to week 3. We're on chapter 9, looking at bonds. And bonds are simply very similar to what we talked about last week. They are a type of annuity where we have recurring semi-annual payments, and we'll be looking at present values, or basically the price of bonds, which are the present values. So there's two specific things we're interested in with bonds, and that's typically the price, or the cost of the bonds currently in the marketplace, and the yield to maturity, which is the same thing as the rate associated with bonds. If you have not read the chapters or looked at the PowerPoint presentation, make sure you go back and do that before you try these calculations in order to better understand bonds. But we're going to build on what we talked about last week with non-annual compounding periods with annuities that we see. Okay, so in order to calculate bonds, there's a couple of different things that we need to understand and look at in order to do the calculation of both price and yields, which we will look at in section 2. But for the first one, let's go ahead and work through this practice problem as we talk about this. So the first one says, suppose our firm decides to issue 20-year bonds with a par value of $1,000, coupon rate of 12%, and semi-annual coupon payments. The return on other corporate bonds of similar risk is currently 12%. What would be a fair price for these bonds that we would see? Okay, so in order to calculate this, we have a bunch of information that we need to sort through. So for this class, a couple of assumptions we're going to make. First of all, we are always going to assume that bonds for our class have $1,000 par value. In essence, what that is, that's the face value on the bond. That is what the bond will pay at the end of the life. So that is the future value of the bond. We're also going to assume in this class, for our purposes, that bonds pay semi-annually, twice a year. So we have semi-annual compounding. Non-annual compounding, you need to make sure you adjust the interest rate and the number of periods for semi-annual compounding. So in order to calculate what the price of a bond would be, we need some information. First thing we need is the stated rate. This is the stated rate on the contract. It's also called the coupon rate or the contract rate. All three of those terms are synonymous to mean the same thing. So for this, we have a coupon rate of 12%. So we have a stated rate of 12%. That's what we see. So we plug that in there. So how many years? Now this is tricky. You got to be careful. Many times there are years on the bonds that we need to calculate quickly. Okay, so this might be a 20-year bond, but there could only be 12 years left on the bond. So you've got to be careful and make sure you read the wording of the problem very carefully to understand how many years are left, how many years of payments are left on these bonds. Okay, so for this one, 20-year bonds, we just issued them, so we have 20 years on the bonds. And lastly, the yield to maturity is the yield, the market yield, or the market rates on the bonds. So be careful you don't get confused on what the market rates are and what the contract coupon stated rate is on these bonds. So for this one, the yield is the market rate. The return on, we find that here, the return on other corporate bonds of similar risk, which would indicate the market, is 12%. The required rate of return is 12%. That is the market yield for investors. So for this problem, it happens to be the same. And we're doing this for comparison purposes to better understand bonds. Now that we have that, we have this information that looks very similar to our present value analysis, time value of money analysis from chapter 6. So we can plug it in. So for bonds, we're always going to assume $1,000 payments. And we're going to assume that we're buying this bond, so it's an investment for us. So at the end of the life of the bond, they'll be paying us $1,000 into our pocket. Our payment. Now, the formula for our payment is found in the PowerPoint slides that I've given you for Chapter 9. In order to calculate the payment, we take our stated rate times the par value on the bond of $1,000. But since it's twice a year, we divide that by 2. Oops, sorry. No, I want my interest rate. So let's do that again. Let's go back, start over. My stated rate, semi-annually divided by 2 times my par value of $1,000. So semi-annual payments, I take my annual rate divided by 2, multiply it times $1,000. That gives me a $60 semi-annual payment. Number of periods on this bond, number of years times the number of compounding periods. So it's 2 compounding periods per year. So there's 40 periods on this. And the rate is the other thing that we have to adjust. since it's an annual rate of 12%, we're going to divide that by number of compounding periods per year to give us 6%. Now that we have that, we can run a present value analysis, a present value function. Our rate of 6%, number of periods is 40, my payment is 60, my future value is 1,000. Once we have all that entered, and we notice that the value of the bond is $1,000. And what we see here, this indicates something very important to understand. When the market rate, the yield is the same as what's issued on the bond, the coupon rate, the stated rate, we see that the bonds actually sell for what's called face value, for the $1,000. So the price of the bond in the market is exactly what's stamped on the bond. But what happens when market rates change, which they do constantly? So what's happened? So let's look at this. We'll look at the second problem. Suppose the interest rates fall immediately after we issue the bonds. The required return on bonds of similar risk, let's say the required return, which is the market rate, drops to 10%. What would happen to the bond's intrinsic value? Those are just fancy terms for what would happen to the market price of the bond in the marketplace. Realize bonds sell in the marketplace the exact same way stocks do. Investors look to buy and sell bonds all the time in the marketplace. So you can go out there and do that. So there are prices, there are values associated with bonds based on different criteria that we're looking at right here. Okay, so we still have the same stated rate of 12%, still have 20 years on the bond, but now the yield on the bond goes down to 10%. Now, one thing we knew, we can shortcut it. If we set everything up right, I should be able to copy these and paste them down right here and get the exact same information, which we do. Future value, face value, par value of the bond is 1,000. Payment is still 60. My 12% divided by 2 times 1,000. Number of periods is 20 times 2. My rate is now 10% divided by 2. And so I can run my present value function on my rate, number of periods, my payment, my future value. Now notice what happens to the price of a bond when market rates fall, when interest rates, when yield to maturity rates fall, the market rates fall, required returns fall. When rates go down in the marketplace, the price of bonds actually goes up. So there's an inverse relationship that we see. When rates go down, prices go up. And we're going to see the other is true as well. When rates go up, prices of bonds go down. Okay? And we have very special terms for those. So when a bond sells for an amount that is higher than its face value or its par value, we call that bond selling at a premium. And when the bond sells below the par value of the bond, it's selling at a discount. Just like you get things on sale less than their suggested price, they're at a discount. So let's see what happens. What happens to interest rates immediately dropping to or going up to 14%? Well, I'm just going to copy all of this. I'm going to paste it here, and the only thing I'm going to change is this to 14%. Now notice, if I set this all up right, I should be able to change that to 14%, hit enter, and everything else changes appropriately. And now we see that this is selling at a discount because it is selling at less than our value. And this one here is selling at a premium because it sells for more than the par value of the bond.